last week I erroneously said that it was the last seminar. So that was my,
That's fine.
My problem.
Less
My
people,
problem.
less pressure, and two of the people here already know.
I'm actually quite
What
looking
I've
forward
been
to it.
doing.
So background
Yeah.
for you guys who don't know, this is Niloofar's master's thesis project. So
Great.
Yes.
Excellent.
So, most of you know me. My name is Niloofar Jebelli, for the people up there too. So, as Andrew said, this is my master's thesis, and I just started this semester as a PhD student, but just finished my master's at the same time. First of all, I want to thank Andrew for advising me and for having the patience to through this journey, and Dr. Kennedy and Dr. Tien as well as my committee
He's
members.
Andrew and I'm Dr. Kennedy.
He forced me into saying that. I was gonna say Dr. Creeks, but it just sounds odd now. So the title of my thesis is Urban Development Through the Lens of Agent-Based Modeling. And so cities are complex systems that transform in size, form, density, land value, and other factors. And key decision makers and stakeholders like developers define and shape the cities. And by simulating their behavior, we can kind of predict what's coming in the future. And so the question of my thesis was, can multiple processes seen in the life cycle of a city be coupled together with an agent-based model to understand developers and the emerging patterns of those processes? So these processes are self-organizing subsystems of a city that rise to a hierarchy that demonstrates the demonstrates in a near decomposability. I can't pronounce that word. To mention Simon, but so the processes that I focused on and were key in the process was urban growth, urban sprawl, shrinkage, and gentrification, and we'll get into all of them. So, to give a background, I'm going to give a lot of background. The models of three of the main models of urban structure are the zonal model by Burgess, sectoral model by Hoyt, and the multiple nuclei model by Harris and Ullman. The zonal model by Burgess was developed in 1925, and I don't know if you can see it great, but it basically has the central business district. I'm going to refer to the CBD, as you all probably know, is in the middle, and you basically have the lower income population around that, factory workers, and then in the outer ring you have the higher income residents. And residentials. In the sectoral model that Hoyt developed in 1939, you kind of have the same idea, but more in sections. And each of these groups have access to the CBD. And you also see this is basically the middle class residentials that you don't necessarily see completely there. And in the multiple nuclei model that Harris and Ullman developed in 1945, you don't really have the same form anymore. And you have the CBD, but then the higher class residentials are further away, kind of in suburbia, and the middle class residentials and lower class residentials are closer to the CBD. And so this leads us to land markets. as I said, I'm gonna give a lot of background
Just a
because
quick,
that's the
just a quick
sure.
question about your objective,
Sure.
Niloofar. So, given the heterogeneity of these, they're all quite different. When it comes to you trying to build a model, do you imagine, for example, could it be the case that you'd have one model where you could then, if it was successful, it could create all these, or do you think that these all need quite different models?
I would say, I think you would need to kind of at least start with one if you wanna. I haven't examined letting the model emerge into another, but I would guess. I mean,
It's
it
transportation,
should.
right? So if you didn't have a monocentric city like you do in your thing, but had a road network like Hoyt would have had, you could imagine that you could potentially generate patterns like Hoyt would suggest.
Yeah.
While if you had a road network roughly to what, or some type of form that would generate that, the seed would be the CBD, and then sort of roads leading out from that, you might be able to generate the other ones as well.
Okay.
That's what I would imagine.
Yeah.
But if considering our project for DITRA, we put businesses at road intersections.
Yes.
And so we're sort of assuming your zonal model by having, but it's again the transportation network. There's going to be intersections, but now will there be more than that? Does every community have a 7 corners?
Yeah, and I think depending on, to put everything together, depending on the assumptions and rules that you put, you could start with one and then have another one emerge. I would believe, but I guess it's easier to go from Burgess to Hoyt rather than completely from like Burgess to, from the zonal model to the multi-nuclei.
And then, as an empirical question, maybe you might be getting to this, so just put it off if you want to. But is it the case that these 3 models would cover 80% of existing, say, American cities are roughly one of these, or is it something like these is really only half of it, or is this like 99.9% of American cities are one of these?
To jump in, to add to that, most of our major cities started as ports.
They started that way, right?
So they weren't road networks, but water network based.
So Burgess one, the classic example would be to split it like, what do you call that lake in Chicago? That it backs onto?
Lake Michigan.
Lake Michigan. So normally, that Burgess model comes out from Chicago, right? Hoyt did look at like multiple cities when he was coming up with his second model. In things like
so
that.
the water kind of puts a constraint on something.
Yeah, but it's still sort of half a monocentric, half a circle.
Yeah.
Semicircle.
Sorry, I'm grading papers at the moment. My grade is right.
Yeah.
And then, okay, so then given that this covers many cities, is it the case, for example, that most cities, most American cities, say, are one of these?
I would say it started more as the zonal.
Okay.
But now we're going.
I
mean, and I don't think not just American cities, but I think cities in general are going towards the multi-nuclei.
Okay.
I would say.
So these aren't models of you're planning to have a city one day and you decide you pick one of these 3. This is what.
It's kind of like the evolution kind
of them.
of yeah.
Although in the United States, a lot of the cities that have that first one were planned to be that way.
Yeah.
They were laid out as a grid.
Planned?
They were laid out as a grid, and so that was the plan, to set up a grid transportation network. And then after that, it sort of grew. It's like you planted a grid seed, and then it just grew out from there.
Yeah. Our Midwest was grids.
Yeah.
So that leads to the land markets, and so and forgive me if some of these, a lot of these backgrounds you probably already know, but I would need to provide the background to be able to kind of lead it into the model and how it was structured. So the land markets form where land is traded or purchased through monetary means or services, and the following factors affected, and land markets also affect them back. However, land use is the management and modification of natural and artificial environments. And 2 of the most famous models of land use are developed by Van Thunen and Alonso, and while the limitation of those models is that, I'll say this without looking at Andrew, I'm going to say the benefits, and they're big, is that they're applied on monocentric city structures, and their static time handling creates a static atmosphere. Their benefit is that they create an abstract spatial representation that allows us to look at a general example of components interacting with each other and kind of like looking at the subsystems as they form dynamics, rather than just getting into the details of geographical cases and stuff. So the Van Thunen model is, and you have that stream that we were talking about, is look at it, it looks at the city in an isolated state. There is, the land is unoccupied, there's no interruption in topography, the soil quality remains the same throughout. To increase profit, the farmers deliver their own crops, and the distance from the center basically determines which crops to that is going to be is going to be growing there, and therefore the rent. But the Alonso model focuses on it looks at accessibility and how that determines land use, land value, and intensity. So basically, Alonso model kind of has the like Burgess has the same idea that Burgess had in terms of agents wanting to be close to CBD, but then there's a trade-off between travel cost and the rent. So the further you are from the CBD, the lower the rent, but the higher the travel cost, and vice versa. And so this is one of the main ideas that I used. Now, I'm going to get into the urban processes that I was talking about, and just to give a general idea, and then get into the model. So, urban growth occurs in two. I feel so bad explaining these to you, especially.
You two have no idea, right?
I was in a city
Please,
once.
I should.
Urbans grow?
They do, actually. So urban growth occurs by expansion and by compaction. So expansion is when the city physically changes in size, and you have an increase in land that's being occupied, and compaction occurs when there's an increase in intensity or density. And urban growth can lead to sprawl. Doesn't happen the other way around. I see Andrew smiling. That's great. So there are two approaches to urban growth, the top-down and the bottom-up. The top-down basically considers urban growth with predetermined and fixed components. It doesn't really allow for the emergence of new boundaries and new regions, whereas the bottom-up not only allows for that, but it helps. It allows for a complex adaptive system to flourish, which is great. So urban sprawl, the word was in my readings that it was induced by urban growth. Not everyone liked that word. So I'm just going to focus on what it actually is. So urban sprawl occurs when the city grows, but its residents want to be close to the CBD as possible, but at the same time, the furthest away from the congestion as feasible. And it's mainly based on population mobility, and occurs in the process of suburbanization. And it's observed as a demand for more space and less density. And these all become important when it comes to the modeling of it. And you can see that a lot among the car-dependent communities. And
Does that mean it didn't happen in Europe? It was a new world?
No, it happened in Europe, but it was enabled by cars.
yeah,
Because traditionally you were stuck by train lines, right?
Yeah.
And before that, horse and cart and foot.
Yeah.
So no suburbia with just trains.
No, you have suburbia with trains.
Okay.
But then it's not like the train
Sprawl.
it's like you were limited on where you could be near the station, right? Then with the car, you can drive anywhere. And you have a four-wheel drive, even more. Sorry.
so now urban shrinkage is a product of population decline by deindustrialization and out-migration from the inner city. And it could have economic reasons like the deindustrialization that occurred like in Baltimore, for example, and or it could have demographic reasons like falling birth rate in Germany. And as I said, suburbanization and de-economization are some of the causes, and vacancies, demolition, and deconstruction of residential properties are some of the outcomes of it. So as we see in urban shrinkage, we see an oversupply of housing and a decline in housing prices, and which causes a faster kind of out-migration from the area.
And I think about that though from the economic point of view. So I think about thinking about Detroit in particular, and so there's there are too many houses, so the houses fall in value, and they're really good deals. Right? You can buy a house for $10,000 in there, right? So why don't you? So when in fact people don't move into those houses, there's some other reason. Right?
What's the question?
Because they see the decline in housing prices should staunch that bleeding, as it were. It should stop the bleeding.
Yeah.
It's an adjustment mechanism,
But-
but it doesn't.
No, because there's no opportunities for jobs, so to speak. So a lot of like this work, I don't know if you comes out of mainly Eastern European countries after the fall of communism. People like don't have to live in the east anymore. We can go west. They're moving out, and also opportunities for industry disappearing. There's no economic reasons for them to stay. Same in Detroit. Detroit, I'm guessing, has very low employment. So even if the house at $10,000, I can buy the house, but I couldn't pay the property taxes.
I would say it's something different even. There's a bit of that in there, but because Detroit has excellent transportation, or at least if you have a car, excellent roads, there are things like, there's actually, in the process of shrinkage, it's, the people who move, so it's not a uniform cross-section of people who move, right? It's people who can afford to move, right? So the people who you're increasingly left behind are people who are problematical, potentially, and then you get things like, for example, like, maybe there's a high crime rate. So one reason why you move out of the city because housing prices, or one reason why a young person does not move into the city because there's a high crime rate, right? Or the other weird things like in Flint, there's exotically high water prices, right? Because there's such a small base of people using the water, you have to charge more per unit, right? And so some city services are, and then of course the schools too. So it's like this is more complicated than just the decline in housing prices is an adjustment mechanism, which should decelerate the migration.
But lumping that some of that, what you're saying, all just under the heading of declining government service.
Yeah.
Because there's not, the schools aren't as good. Law enforcement diminishes, so as in line with crime going up at the same time, and that just gets worse and worse. Hospitals shut down. So all these government services decline, and anyone who's thinking about it might say, oh, you have a good price for a house, but I might not live the year living in the house. So that may play into another limiting factor of.
And there's also the beauty contest part, which is basically that. So if in fact you anticipate something like this might happen, and you own a house, and you think your house is going to be worth less in 2 years than it is right now, you have incentive to leave
Yeah.
You know, instead of to sell it
Yeah.
now and get out, but that just accelerates the whole process.
And it doesn't, in a lot of cases, I think it doesn't, there's not an opportunity for developers to come in and reconstruct stuff, because, I mean, those other opportunities like jobs and everything have to relatively be there for developers to see the potential in an area to be able to
For developers.
to come in.
So what's
Because-
the,
oh, go ahead.
No, I was going to say that from a modelling point of view, urban growth well established, gentrification has been well modelled,
Yeah.
things like that. Urban shrinkage,
Not so much,
it's like,
right?
I think there's 2 free paper on it,
Yeah.
from an ABM
Yeah.
side of things.
That is the case.
Yeah.
Cool. That's just something that's very fertile thing to think about.
So the last process is gentrification, and the dictionary of dictionary of human geography. I've said urban development, urban dynamics too many times. Human geography defines gentrification as middle class settlement in renovated or redeveloped properties in older inner city districts formerly occupied by a lower income population. Now there are 2 sides to gentrification, and I applied them in the same sense to the model. There's the demand side, where for whatever reason a group of higher income residents decide to move into the inner city and basically raise the price of the properties. And the supply side is when there's a rent gap, and I'll get into that, that attracts the developers to come in, renovate, and the renovation causes an increase, obviously, in the prices, and kind of pushes out the lower income population. And it's measured by the displacement and decrease in a group of people, as well as an increase in the housing price. So the rent gap that I was talking about, the rent gap theory, is developed by Smith, and in 1979. So basically, what it says is that there's a capitalized rent, which is the actual rent of a property, and the potential rent, which is its potential rent at highest and best use. And so at the beginning, they're equal. And as time passes, the potential remains the same, and the capitalized rent decreases. So it creates this rent gap between them that when developers identify, they can then, I mean, with other factors obviously, but get in there and invest in that area, and there's a potential for profit to be made. So I studied a lot of different models, and looked at various theories and everything. And some of the main ones, I just wanted to point out some of the main ones that give me inspiration, and I used some of the ideas from them for my model. And to just give a general example, the Schelling model, I used it in an economic status sense, where I'm going to get into that more in depth. But one of the preferences of the agents is that they choose their they become happy as one of the parameters. One of the factors is that if they have at least one neighbor of the same economic status as they're in. So yeah, it's generally for inspiration, and use some of the ideas from them.
How's it calibrated?
What?
How is the Schelling model calibrated?
I don't remember when I made this table, actually. But I can get back to you on that.
Sorry.
So the main data sources, and this is obviously not all my references, but this is the main data sources that I used to put together the model, are from these sources, but mainly the census, the U.S. Census, and for income, budget, and things like that. And for the properties, I mainly use the MRAS, the Metropolitan Regional Information System, yeah, for property sizes and for property prices.
What you really want to say is you use this data to stylize your
Yeah,
model,
definitely.
not,
Stylized.
Okay.
So the model is stylized after stylized on the data from Washington D.C., but it's an abstract spatial representation. So by no means do I are the regions in D.C. that way, and obviously it doesn't look that way. But I needed to use actual data to be able to make sense of some of the, if I didn't want to just invent housing prices and everything. So I stylized it after, on Washington, D.C. So the model is made in, built in NetLogo. I used ArcGIS for creating the zones and the tessellations, and then Python for kind of visualizing the output data. And this is the CBD where the developers are, and they are fixed. So when you start the model, they never come out of that zone. But the other agents move around, and there are two groups: the professionals and non-professionals. And what I mean by that is the professionals are the higher income, and the non-professionals. I'm sorry, I'm like not looking that much this way. The non-professional. I'm sorry, it's because of this. The non-professionals are the lower income, and so you have the inner city and the suburbia, and. So there are many input parameters for, these are for the agents, the developers, professionals and non-professionals, and they all have incomes and budget and savings, and these are, as I mentioned, all based on the data sources that I used. The only difference is that the developers have the net operating income, and the rest of the agents have housing budgets. And again, the percentages, for example, 69% of annual income is budget. This is all from the, I believe it was the Urban Land Institute. And then the property parameters that are important mainly is the size, the price, age, and then the potential, the PR and CR that you're going to see. So these were mainly the numbers that I needed to have, and that's why I needed to use the MRAS information and kind of like stylize it based on some data, some real world data. And so the environment parameters are basically the parameters that you can also change on the, and I'll show that. You can change throughout the model and kind of get, this is what mainly I played with to get the outcomes for each of these urban dynamics. And I also ran them definitely by the defaults.
On the data you got from CBRE, did they charge you for that, or did you have to pull any
No,
stuff together?
actually, I found a report
Okay.
for their, I think it was 2014, or no,
Okay.
15. I have to check, but no, they didn't. The only thing that I had access to, because of my, I have the, what's it called, the real estate license for Maryland, and the MRAS, some of the data, you kind of needed an access through that, and I had that data. But I put them all together, and I have them. So I can always give it to people. As I mentioned, that gentrification has two sides. I also applied it to the model, in that way, and I'll show you the model logic in the end to kind of put everything I'm going to say together. So, so this is the process of how the gentrification by supply occurs. If a patch is if it's occupied, if it's not occupied, then you calculate the rent gap, and if any developer, if the developer's saving is more than the property price, they can buy it, and then the patch updates by taking the color of that developer so that you can kind of like track who's getting what land, and the age of the property changes to 0. So it's kind of like a notion of it was renovated, and then that changes the developer's NOI, and so just to kind of explain that part too, the P stands for the price, the R stands for the what's called I believe price to rent ratio, which for DC is 32.02, and it's kind of like a way to arrive from the actual price to the rent price of a property, and to arrive at the capitalized rent, I needed to use a decaying factor, and so that's what the lambda and everything is for. And then the rent gap formula, I just took it from Smith, and yeah, and the NOI was just calculated by putting the cap rate and the house price together. The gentrification by demand occurs, so the data I got was that 51.9% gentrification occurred between 2000 and 2015. And I needed a portion of that, because to apply all of it would have changed the model drastically. So I took a portion of it and applied it in the same kind of like time steps, thinking of time steps as years. And then yeah, gentrification. The gentrification population then is arrived by the gentrification rate and the suburbia. Well, the population of professionals in the suburbia. So the way this occurs is that every 15 time steps, basically, the lowest income of the professionals, so the higher income people, move from the suburbia to the inner city, kind of causing that gentrification by demand to occur. The sprawl density is obviously very important in the process of sprawl, and I put a threshold so that if the density is it becomes more than the threshold, then a number of people can move out to a less dense area, and yeah, so and higher density yields to higher prices, and this is all visible in the process of the model. And the urban growth is also urban growth and urban shrinkage. I used the rates that I got of the growth population in a span of 15 years, being 17%, and so I applied it in the same way in 15 time steps, and the urban shrinkage. It's the same kind of concept of 25% every 50 time steps. And now, because the model is not extended beyond the zones that I demonstrated, when the city shrinks, the leaving agents basically die in the model, which in the end I'm going to get to that, like note that and make a point about it. And so this is the general logic of the model, and you can see the interactions of these different aspects with each other. And yeah, if you have any questions about this, it's a little.
Is it necessary to have many developers, or can you just have one developer?
I think I have 5 developers, and the reason for that was that I tested very early on with lower number and higher number, and it would either kind of like finish up the process too fast, or if there were too many developers, or if there were lower number of developers, it would just take a lot of time for, and I had to like run it for like 600 time steps, for example, but this is for 300 time steps. And a lot of processes emerge after about like 100 time steps. It also depends on the number of initial population, and I'll get into that. So, talk about that a little bit. So the model was tested for 300 time steps and 20 times for each combination of parameters with seed and with no, I put 300 initial population because I changed it throughout. Anyways, yeah, and these are the default values that I had also earlier in the other tables. So this is how the model looks like when you start, and as you can see, these are the parameters that I said that I could like play with, and each of these affect one or more of the processes. And I have these monitors to kind of like track what's going on, but I used behavior space to get a better visualization of the model. So for the sake of time and for the sake of kind of to just demonstrate a representative representation of what I have, I'm going to show you the default, the results for the default setting, and for a bit of the gentrification by supply, which was very interesting to me. So when you run the model for 300 time steps, a lot of stuff, kind of like for the default values, makes sense. Now, you might be wondering what that is for. This happens because initially the developers have a limited amount of money, a limited amount of income to be able to buy a property, and it takes the agents time to increase their savings to kind of like okay, so when the agents buy a property, their savings become negative. So it takes them time to kind of build on that. And then this is, you can see that in the developer saving. So, yeah, so and then you pretty much always have the same kind of pattern throughout all the runs. For the NOI, I think the NOI kind of goes pretty well with the developer savings in terms of behavior. This is just to demonstrate that when you can see that the yellow developer is kind of dominant in this. Well, it's not in this one, but you can see that in that. I just wanted to kind of like demonstrate the dominance of a developer in an area.
So the yellow color in the thing is the developer's color.
Yes. So
okay.
Like I said, when they develop, two things update the the color of the patch to the color of the developer it developed it, and the age. And so. Two examples of the inner city population and the suburbia population. So the spikes in the sudden decrease in the suburbia population occurs due to the gentrification rate. I mean, the gentrification by demand that they, like I said, the lower income group of the professionals move to the inner city. So you kind of like every 15 years you kind of see that spike. And one second, sorry. Okay. And one of the things I really like about pretty much all the results I got with any combination, and you can see it in the default, is the emergence of sprawl after a certain, after growth occurs, which proves the point that the growth kind of leads to sprawl. And yeah, so, and this is a demonstration of kind of like the evolution of the model. So here it's at, it just starts initialization, and this is the time steps go as 50, 100, 150, 200, and 250. And 250 and 300 were very similar, so I just like kept it at that. And this is all at the default values. And I wanted to give an example of a different combination rather than the default, and I chose gentrification by supply because I just think it's an interesting behavior that you could actually see in the model, and it's pretty visible, and it occurs through the dynamic that of the rules and the assumptions. It's not just some rates that I gave it or whatever. And here, I have gentrification rate and cap rates of the same value, and the only thing that changes is the population, from 100 to 300 to 1,000, and you can see how fast sprawl occurs because of that, and you can see the effect of like density on the emergence of sprawl. So, I mean, I'm focusing on sprawl. There's a lot happening, but I just love how it kind of shows the importance of population size in the model. And this is just a representative example of the gentrification by supply. So to kind of like conclude, like I said, the population size is a very important factor, and some of the results showed this behavior that I'm going to explain, but unfortunately I couldn't like really show it in the for the sake of time. But they show that lower population and lower growth rate creates a coexistence between professionals and non-professionals in the inner city and suburbia. So the lines for those are like very close to each other in the plots, and but lower population and shrinkage rate create a dominance of professionals in the inner city. And like you saw, urban growth kind of generated the urban sprawl, and gentrification by demand and gentrification by supply were pretty visible through the model. And you can see that how the increase of development limits the opportunities of certain agents, like mainly the non-professionals, because as they start developing properties, these non-professionals don't really have the income to be able to, or the savings actually, to be able to purchase those properties. And the actions of these agents affect the actions of the others. And you can see kind of some, let me see if I can show you this. So yeah, you can kind of see it here that the setting that I was talking about, the preference of being near an agent who has at least one agent of your income group causes these kind of like mini clusters to form. And they could form, but it's just like, it doesn't have to be the same color of people. And so that could be an interesting notion for developers. The developers that developed properties close to these clusters have a higher chance of earning more money because more people are going to be closer to these clusters than if they construct properties somewhere else that not a lot of agents are around. And and for further work, I would say redefining and introducing new rules and assumptions could be helpful, and smoothing out and this is your advice, smoothing out the rates definitely, the gentrification rate, growth rate, and shrinkage rate throughout every year. So it's not like every 15 years or every 15 time steps you see a spike or anything. It's smoothed out through a time. And maybe experimenting with cognitive aspects of decision making, especially maybe for developers. Applying the same kind of idea to the sectoral and the multiple nuclei models, and adding features like transportation, cost of construction for developers, cost for agents like utilities, and intermediary agents, and Nigel Gilbert actually has done that with realtors, and development regulations. So adding these features could be helpful to getting a better understanding, and like I mentioned, kind of like increasing the expanding the kind of geography of the model, so that you can see when shrinkage occurs, for example, or a sprawl occurs beyond the boundaries that I have. So these are kind of my ideas for further work, and that's it. Thank you. That was me. So yeah, yeah.
Thank you, Nil.
Thank you.
What about employment? You have no employment in your further work.
Yep. When, like adding the.
If no one had jobs.
Oh yeah.
Sorry, I just thought about that right now.
Yeah.
Is it easy or hard to build it in?
It's beyond the. Sally has my thesis.
Does Gilbert have jobs in his model? I don't think he does.
No, he just has buyers, sellers, and an estate agent.
Yeah, you get those chains that do it.
Yeah.
I think there's a lot of things that could be added. I initially started thinking this has to be very geographically on point, or it has to have these specific things based on DC, and I've grown to appreciate the abstract representation. No, seriously, not because you forced it. No, but I really have grown to appreciate that, because it allows you to really see a lot of things forming, and allows you to put in aspects and not be kind of like bound by specific outlines or specific geometry. So
because one of the challenges in general with this type of model is most people just look at one subsystems. If I was trying to put it, like they would look at gentrification, but they only look at the supply side, not the demand side. So others would look at growth, but not shrinkage. So Niloofar was trying to merge all these different concepts together
and weave them into city cycle.
It occurs to me that you're looking only at housing, not the business side.
Yeah, no.
So you're not.
I am not.
you're not building taller and taller skyscrapers and knocking down 10-story building, put in
No.
30-story buildings.
No.
Um,
It's literally like every patch is a property, and there's
Yeah.
like no room to walk.
Well,
So
yeah.
yeah, pretty much.
But it would, does the business center grow the same way as the residential areas?
There's no property in that area. It's just like a hypothetical business center, and nothing really happens there aside from.
But no, I mean, the
develop-
processes.
Oh yeah. I mean, like
Um,
obviously they definitely have developments, and even in central businesses, like in real world cities, you have housing in central business districts. They're super expensive, obviously, but you have them. But these are this model doesn't really consider
I'm
that.
trying to remember in the city of London, which is like the CBD, has like a couple of thousand households in it, but not many, because it's.
Yes, yeah.
Yeah, you go up around it, yeah. So
Right.
I'm trying to remember how many people live there, but it's not many.
Are they? Is that like? Are the people who live there? Are they like? Is it like governmental housing, or kind of like
Yeah.
Prime Minister lives in the like
Well,
something?
he's got
like-
a home,
Yeah.
yeah.
No, it's.
Well, I was looking at the cars that seemed to be parked near them, and they seemed like normal cars. They didn't.
Really?
They weren't all Bentleys.
Yeah, because they pack in the Barbican car park.
Well, that's what I was looking at. It was a Barbican parking lot, and the apartments right around Barbican.
The
And-
question is, where do you stop if you're trying to model a life cycle of a city?
Yeah.
Yeah. Well, I was just curious if the business side developed using different processes, because it needs to have to convert from industrial to information-based industries to governmental or something like that. If is that driving the rest of it, or does the residential drive the urban?
I think they both affect each other, kind of. Yeah, but
Okay.
I would say if I were to model the bring in the firms, I would like to look at a multi-nuclei kind of model to still maybe keep it abstract, but look at a multi-nuclei. So I think that it allows for a more industrial kind of like space.
There must be rules of thumb with respect to not with respect to tech firms, but like for a McDonald's to function, it needs X number of customers.
Yes.
For schools, you need X number of students. So you could probably.
There is one for businesses too. How big of a city? No, it's the other way around. If the city population is this size, how many McDonald's can it support? How many pharmacies does it need? How many?
Yeah.
And the Department of Labor puts that out. I think it's labor.
So that's kind of the snapshot cross-section. But I think, there is a preeminent theorist of this. I don't know what your opinion of her is, Andrew, and I don't know what Mike's opinion, but for my money, Jane Jacobs is the one who's written the best about kind of the organic growth from the bottom up of cities. So how does a city kind of add another 1,000 people in this neighborhood? Well, you can't just do that. You have to have things like you have to have a restaurant, and you have to have a dry cleaner, and you have to have a 7-Eleven or whatever. And so that process of organic growth is very bottom up, and it's each one of these economic entities taking its decision autonomously, but based on some calculation that's private. We don't really know what it is, and that it has to be very much this organic process was her claim. Now, in one of her books, I don't know which one, she actually has like diagrams in the back of it. There's an appendix which shows like how things bulb. She's just kind of like bulbing process, where it's kind of like she used biological metaphors like how does a potato grow, right? Well, it adds layers of growth on, right? So there's a whole. I think there's lots of interesting analogies for how this stuff works, but I think it's best that there are no satisfactory models.
Life and Death of American Cities. That's not.
She has like 5 or 6 books, right? I don't know which one of the books. I think it's the first one. It's about survivalist. I don't know what it is. I probably had it. And then I think her thing also has that potential to get things like, you know, you also will get green space to form, right? And then so what a lot of the CA models have is the CA models, when they're going to try to get, you know, openings to, or open space to be part of the system too, right? So you get the
Mhm.
fractal dimension.
Ah, yeah.
Which is another complication, I think.
Yeah, because we don't even go down the procedural city route as well,
Yeah.
which is trying to get the road networks correct and things like that.
Right.
There's another model, very few models try to actually model the road networks.
Very good.
Cool.
Thank you, Niloofar.
Thank you again.
Yes, thank you very much.
So I'm going to be on a panel, and I have to go to some talk with, in a couple